got to do here is we've got to put the masonry reinforcement in there to counteract the adverse effects of an unreinforced panel. It's pretty obvious what would happen to a panel of brickwork like that under normal loading. We would very quickly get tensile failures at the bottom, and we would have a pile of rubble sitting at the bottom of here, sitting on the ground. So what we do first is introduce the helical reinforcement in the bottom section of the panel down here. If it's properly grouted in, the tensile forces that would have cracked the panel is transferred through to the masonry reinforcement. Okay, and that takes care of the tensile forces that would have cracked that panel. Because we're looking at a beam, we're going to generate compression forces towards the top. So we have to generate an area of compression, or an area of masonry that we know will accept that compression. So we normally introduce the same 2 cords of wire into a slot towards the top. What that does is it ties together at least 2 courses of masonry. We've got the section of grout with 2 bars in it, where we generate a zone which we know will accept the compression. The vertical shear generated by the beam is actually carried by the bars passing through this point here. And the horizontal shear of the building, which is the tendency for those bed joints to slide over each other as that panel flexes. We're reliant on the bond of the existing masonry, the existing mortar to the masonry to resist that, because we haven't put anything in there to resist that horizontal shear. We could do, it would normally involve vertical pins through those to actually physically tie those bed joints together. Now, in most construction, we don't get the opportunity to do that because people don't want vertical spots cut in the face of their brickwork. So, we're reliant on the existing construction. So what we're getting at here is the existing construction has to be of a quality to accept the system. The easiest analogy of that is if you've got a pile of bricks, I don't really care how much wire you put in it, you've still got a pile of bricks. And indeed, in certain situations, the best advice to the client is to take down and rebuild. The methodology, the structural methodology associated with these systems was generated by the BRE. So we've got all the maths associated with what I'm saying. We haven't pulled it out of a hat. The BRE have done extensive testing on the use of masonry reinforcements to form masonry beams within existing structures. And what we've got are these load tables, which gives us the actual ultimate strength of a beam in kilonewtons per metre, given its span, 0.8 up to 3.6, and the actual depth of the beam. Obviously, the deeper the better, in common with any other beam construction. And what this basically means is certainly some domestic loads, domestic type openings, we don't have a problem enabling the masonry to span over that type of distance. In certain areas, if you wanted to start forming very large openings, so 3.2 metres or even 3.6 metres, in highly loaded situations, you may have to come back and we would have to do a bespoke design for that particular application. But what this means is that most applications are well within the scope of the actual system. We have to be able to test it. There is a minimum requirement for the capability of the masonry to accept horizontal shear that is assumed in the BRE methodology. And we have to be able to test that on site where necessary. We've got this nice little shunt meter which is introduced into a raked out brick curb. You rake out the adjacent one, you basically try to shift the brick sideways. So we have an on-site test to allow us to test masonry in the field. How do we get the wires into the wall? We're normally working into bed joints. The reason we put it into bed joints is a convenient place to hide the system. Structurally, we could go straight into the actual face of the masonry. We could actually go into the face of the masonry itself. Most people want it hidden, so we're working into the actual bed joints. This piece of kit that we've had adapted for the use is a modified wall chaser, twin-wheel diamond blades, and this one that we've actually using here is a modified clipper machine, and it's the only one on the market that will cut 65 millimetres deep in one pass. Not that we normally cut 65 millimetres into masonry, but what this allows us to do is cut the 45 millimetres that we do go into masonry through applied finishes, being external render or indeed internal plaster. So you don't have to take the applied finishes off to actually cut the joints in the wall. The other advantage of this that piece of kit, it's got a vacuum extractor on it, and it makes its own 98% dust free. So our contractors can quite happily work on internal domestic properties without having to decant the tenants and have extensive dust cleaning operations. Wires cut to length with a set of bolt props, very straightforward. There we can see a beam application. This was a failed Bessemer beam, and we just formed the masonry beam to take the beam over the panel of masonry over that Bessemer. You can see that sort of step crack there associated with the sort of traditional triangular cracking you get in that type of situation. Mix the grout up, done the grout into the back of the slot, push the bars in. The same structural works we normally do 2 bars per slot. The grout's then left 10 to 15 mil behind the face of the brickwork to allow for subsequent repointing. In structural beaming works, we normally have to do something with the crack. We have to stabilise that crack, certainly within the beam zone, as we call it, i.e. between these top and bottom chords. And you can use resin injection. Some people still use slate resin investment. What we would normally do is just rake it out, and we actually use the non-shrink grout to stabilise that crack. Once that's done, repointed, and that's the job. And that beam will take the place of the rest of the beam that has failed underneath necessary. Right, going on to some of the pinning applications we've got here. This is utilising normally the thicker wires, the larger diameters, the 7 and 9 millimetre diameters. What we're doing here normally is drilling a pilot hole into the masonry, which takes the core of the actual bar itself, and the helix, as it's actually physically driven into the substrate, cuts its own helical path into the substrate, providing a full length mechanical fixing with the substrate. There's no expansion, so we're not looking at the sort of normal expansive forces of resin expansion ties. No resin, it's purely mechanical application. Extensively used for cavity wall ties, that type of thing. So we use it throughout the applications that we use. Grout ties, cementitious grouted in tie. This is grouted a helical bar which is introduced into a clearance hole this time. So we're typically looking at say 16 mil clearance hole for the 9 mil tie. Introduced through a long pinion nozzle. We have pneumatic versions of these guns if you haven't got hot wire working with it, so you can get hard work squirting the grout and the pins down along the injection tube. Obviously you need long drill bits to drill long holes. You can see here, this fracture down here, we're actually tying across it by utilising the bars as a grout tie in that location. Some applications now. Window lintel replacement. This is traditional solution. That's what normally happens. Window replacement scheme. You've got to support that area of brickwork immediately above. That's a traditional solution. Take out the affected area of brickwork, put in a lintel arrangement, whatever it is, stainless lintel or whatever. Rebuild the brickwork. Believe it or not, that's a good one. So you can downside worse. Not particularly sympathetic. One like that you get away with, you can sell somebody a bit of tradition and ivy, it'll cover up quite nicely, but it's not the solution in a 2,000 house council estate. What we do normally is we form masonry beams over the openings. So the introduction of masonry beams, we allow the actual structure to span over that opening without the use of conventional